It really is great to see the room so busy this evening. It's fantastic. Thank you very, very much indeed. Just a few words of welcome and a few points of housekeeping before I hand you over for the real reason that you're here tonight. So the first one is that we are going to record the presentation this evening. I don't know if the speaker actually knows that, but but we are going to record. So, and again, that's for all your colleagues who possibly haven't been able to make it tonight but are genuinely interested in the topic. So, always we say, please smile, because not only do we record the speaker, but we take some shots of the audience as well. And if you wouldn't mind, please put your phones on silent. There's nothing worse than somebody's really embarrassing ringtone coming out in the middle of the session. Thank you. We don't envisage there being an emergency this evening, but if there is, the exits are at both ends. Oh, the door is hidden in the corner. I apologise for that. The emergency exits are at either end, and we escape to the front of the building out onto Sheikh Zayed Road. If you need a different kind of an emergency, the toilets, they're located back out opposite the elevators where I'm sure you came up to come to the event this evening. I'm delighted to welcome you. My name is Craig Garrett. I'm the manager of this academy that you're using the space of this evening, and this is really what this space was designed for, is for events like this. So we're delighted that you could use this and take this opportunity to make use of this space. And my colleague Arun, who does the IT magic behind the desk there, also manages the academy with myself. We're based here 100% of our time, and Arun will be the one who will be recording the event as we go. Yeah. Just a little bit about the academy. This is our sort of mission statement: partner with industry as a catalyst for thought leadership and knowledge exchange. Of course, you're the industry that we're engaging with, so it's perfect that you're actually here. And our big thing is knowledge exchange, and that's exactly, again, why you're here tonight. And I think that's why it just fits perfectly with what we're trying to do here. That we have one side of the industry looking to educate the other side of the industry with their knowledge and their experience. So thank you very much for being perfectly aligned with what we are trying to achieve here. We have 7 academies globally. You've seen our spaces that we have here, and they're all available free of charge. And we have a set of standard courses that we deliver. If anyone is interested in any other information to do with the academy this evening, then please feel free to ask us, but that's not why you're here. Just wanted to say a couple of things. The first one is that there is going to be some catering. So please do not leave without helping us eat this catering that's going to come. Otherwise, a very few people are going to have to eat a lot of food. So please remember, don't leave without helping yourselves to the catering. There is also some registration pages are being circulated. So if you've came in late and you haven't seen that, we're just trying to record everyone that's here. We know that some of you have registered online, but we know that there also might be a few people who haven't. Little bit of a plug from my Bentley colleagues who have asked me to mention that, of course, we're here tonight to hear from VSL, and we're delighted that such an industry leader in that field should be here. And they want me to unashamedly plug the RAM Concept Bentley product, because that is something that's used that is associated with the product. And again, if you want more information on that, please see myself or some of our Bentley colleagues. And it leaves me just to hand over, first of all, not to the speaker for this evening, but first and foremost to the current chairman for the IStructE, Sama. Would you like to come up and introduce tonight's event? Thank you.
You all on behalf of Institute of Structural Engineers. I can see number of new faces which we generally not see. So how many of you know IStructE structural engineers are connected already? How many of you already connected with IStructE structural engineers? Oh, so many numbers are new, so it's very good. So it's a great opportunity for us to introduce yourself or as an institution to you. So today, first of all, I thank you very much for Mr. Craig to arranging this platform for us to introduce us as an institution, as well as today's topic, which is VSL. So today's topic is Mr. ANNAN. Our speaker is Mr. ANNAN. He is technical director of VSL. Is from Technical University from France. And he is instrumental in developing technologies. What is that? Cable stay technology, correct? I'm new to the cable stay bridges. From lot of people from Middle East, we are very new to cable stay, basically. And he's very active in FIB and PTI. I'm requesting Mr. Anand to take over dais.
Good evening. Thank you very much. Thank you for all of you being there. I'm a bit impressed, so you can pardon me if I eat my words. We're going to talk tonight about stay cables and development of stay cables and stay cable design, making use of stay cable. And of course, you may have a lot of questions. And please, at that time, if you wish, can you ask directly right now the question on the spot so that we can have a bit of interaction into this speech, and this will help me to progress in my speech. I will go shortly as an introduction, presenting the VSL company very quickly in terms of offer, and then of course talk about stay cable. First, in the point of view of components, what is components of stay cable, and then a bit of a word on development, because lately stay cable technology have evolved. Pushed by the market, pushed by the needs, the desire of owners, of architects to make it better. So this is what we're going to go through. Few slides. So this is the big WIG group company, and VSL is there. A very small company at the bottom, but very innovative. This is why we are here today. A bit of history. VSL has been built as a spin-off from Losinger. So Losinger is a Swiss company, which was known worldwide at that time for construction. And VSL, meaning a Vorspann system Losinger, has been created around a patent of how to anchor wires to an anchor head and transfer this force to a piece of concrete, basically. We call it post-tensioning, eventually. And VSL has been developing the wedge for this 7-wire strand. And from this concept, have developed post-tensioning, stay cable, heavy lifting, and other applications making use of strand and anchor head. Hi, welcome. And this started 1960, and then till now we have developed and broadened our offer to many solutions, application, technologies, and so on. So in few numbers, VSL is around 4,000 people all over the world, and managing patent as any innovative company defending their developments, where you can find VSL on Earth. Basically, VSL works on various technologies, bridge construction, foundation, ground engineering, containment structure, repair. In terms of technology, we're talking about post-tensioning, classical core business, bearings, stay cable, of course, which is the topic of tonight, heavy lifting, and geotechnical. Bridge construction, so this is something we have been aware here in this region. Bridge construction, we have been quite active there. Foundation, diaphragmal, I'll go quickly on all this. Can you talk to me if you need more detail on some of these aspects? Containment structures, and of course, last but not least, repair and retrofit, which is the new challenge of tomorrow, maintaining a huge park of existing structures. And this over past 60 years. Many references in many different fields, and a lot of them is about bridge construction. So let's now enter into the heart of the topic, stay cable. And just a bit again of history about stay cable. First stay cable bridge, 1978, and then since then we have keeping developing, and eventually with various solutions till now. So here we are. In terms of stay cable, we're going to look at it from the point of view of components for the beginning. Stay cable, everyone knows what it is. It's a cable structure transferring force from one point to the other. Today, in the perspective of a new recommendation and new code, it's seen as a family, 5 families of components. The first one is an tensile element, this strand, which is transferring the load from one point to the other. Second, the anchorage, transferring the force from this one strand to the structure. Yes, please. Just I take opportunity to remind you, if you have any questions, do not hesitate to raise your hand. I'll be happy to answer. So we're talking about strand first. We call it the main tensile element. This name, you can see it in the recommendation. International recommendation. You can see it as well in a design standard and codes like Eurocode, tensile element. And then we have the termination. The termination is a word used in Eurocode. It means the anchorage. It's the component transferring the load from the strand to the structure. Then we have the cable encapsulation, classically the stay pipe, and all the families of components associated to the stay pipe. What is this cable encapsulation? It's the interface between the cable and the environment. It is what the cable sees from the wind, from the dust, from everything coming from outside, including UV and so on. Then we have the protection of the cable at deck level. Quite important is where the cable is an interface with the user. It's where the user can touch the cable, can impact on the cable itself. And eventually we have what we call transition device or deviation device. Is this cable, stay cable, this particularity is it to be exposed to wind, to environment, and therefore it will be subjected to wind forces, wind loading, making deviations, transverse loading, and therefore we have to accommodate this and cater for these deviations. So we have devices. So this is how we're going to structure that speech. If you have any question, please raise your hand again.
Actually, yes. Can you
Please.
elaborate a little bit on the vibration control?
Absolutely. I will do it in a few slides. It's a good question. Oh, sorry. It's okay? This is okay? You have this in mind? So now in terms of application. Today, and especially in the perspective of the FIB code, systems have to be modular, meaning that you can have a technology of strand, a technology of, say, of anchorage, and apply it on various different applications. And this offers some design opportunities. Basically, we have a cable. We have 4 different family of applications. We have stay cable bridge, long span structures, long cables. We have what we call extra dose bridge, where the quantity of live load compared to the permanent load is much smaller, permitting some optimization into the behavior of the structure. Then we have hangers, roof cable, vertical. Then we have, to the other extremity of the application range, what we call bowstring cables or tie downs. And all these different cable application, we can give a bit of classification. I just change the slide. And this classification is made from the point of view of the loading, whether this loading is inducing is a high fatigue loading or where there is more deviation or combined. And from this loading, what type of permanent force we accept to have on this cable. Or let's say it differently, what part of the capacity of the cable we accept to have as a permanent force, and what other part is left to cater for safety. So if we go with stay cable, we have high fatigue loading, high deviation potential occurring, and therefore we do not occupy more than 50% of the capacity for the permanent load, basically. If we go with exposed cable, we have a moderate fatigue loading, we have low deviation, and therefore we can go beyond in terms of permanent force. Hangers, these depend on the application. We can have hangers experiencing no fatigue loading, and others with high fatigue loading. And therefore, this is a decision of design. What is the maximum force we can have in permanent situation? Bowstring cable, usually you have very low fatigue, almost no fatigue, no deviation. Tie-downs, you have low fatigue, but you can have extremely high deviation.
What's the acronym for GUTS? You've got 50% GUTS.
Good question. GUTS means guaranteed ultimate tensile strength. Is basically your cable capacity. Your cable is failing 100% GUTS. 50% GUTS means that you have reached half of the capacity of the cable, basically.
Is this the initial load you put on the cable when you construct, like, or is the final capacity? Look, you can only stress till 50%, like when you put it, like.
This value usually is the one you have, what we call it, at maximum service state. It's a maximum service load, meaning that if you anticipate to have on your cable a high service load, for your permanent situation, you would stress it initially at 30%, for example. Yeah. So finishing with tie-downs. Tie-downs are cables which are used to restrain a deck of a bridge against the abutment. And most of the bridge, they elongate with temperature variation. And therefore, this cable can experience very big rotations. So then you have to judge as a designer what would be the maximum force in this cable in service upon the potential deviation you may have on the tie-downs. So from this classification, VSL, as a stay cable supplier company, is offering a portfolio of solutions. And what is important with these various type of solutions for each application is that they can be combined together. Typically, tensile element, we have various technology of strand. And these have to address the situation of the structure, basically, the exposure to environment, how harsh is the environment or not, the type of loading you expect, and very important, the normative frame in the area, the design codes. Typically, in the USA, is not allowed to have galvanization on the strand on federal projects, and therefore you have codes developed for the use of this type of strand without zinc. For the part of the world, you can use zinc, so it makes the technology a bit different. Why? Sorry. Why in the US we have no zinc?
No, why Americans are not allowing galvanization?
You want which answer on this one? I think it's galvanization is a technology which is extremely polluting. One reason is not all of them, is that galvanization process is highly polluting. Polluting, correct. Polluting. But it's not only this reason. But today, what I know for sure, they are developing a code, a design, or a normative to have zinc into the US as well. But for the moment,
Because of the heat changing the performance of material?
this is true. But it doesn't mean it doesn't work. When you have a material and you apply a zinc process, you change the characteristic. This is true. And therefore, we have different requirement for strand with and without zinc. This is very true. Yeah, correct. and especially if you have silicium in your steel, and then you have a bigger impact on the zinc.
Yeah, you're going to have brittle.
Exactly. Talking about transfer component for transferring the load from the strand to the structure. Same, we can apply various different solutions. Solution with anchor heads, solution with clevises, and solution without any anchor, just by deviation. We introduce the load to the structure through a deviation of the cable. We call it a saddle. The encapsulation of the cable, the stay pipe, has to accommodate the environment, which can be of various form. So it's here to provide to the cable a satisfactory behavior in terms of wind impact. The wind impact is of two nature. The drag first, which is the force that the wind is introducing onto the structure, making it tilting. This is one aspect. The other aspect is dynamic. How the wind is exciting the cable is one aspect of this. Then you can have effect, other effects of the climate. Snow, for example. You can see it later. And of course, the cable is the biggest part of the structure, which is, can be seen by users, and therefore it can be a subject to architectural features. Let's call it LED, and then we can see how LED impacts a cable in terms of design, for example. Then we have protection, various types of protection, basic protection, fire protection, blast protection, all of these being required or not, depending on the structure. And eventually we finish with the deviation device, which can be dampers, which can be guiding device, which can be just nothing, just a compacting element to maintain this compact shape of a cable. So we go one by one on all this family. Let's start with the main tensile element and coming back to your questions. Today, the standard is this strand, I don't know if it works, which grade is 1860 MPa. This is a new standard which has evolved from the former 1770. Today, the strand industry has developed into a higher grade, 2160. So the industry of wire is increasing the capacity of strand. And today, of course, VSL is proud to have been fully qualified for this application.
Is there any reduction in the extension for failure?
Is there any reduction?
In the extension of failure for the
You mean,
strength?
can I turn your question into, is there any loss in ductility?
No, I didn't ask that. I said
Extension. You mean elastic extension?
Yeah, because that you have got a certain extension upon which you should not allow any further for the ultimate. Yeah?
So your levels is the same.
Relaxation?
No, extension, not relaxation.
So if you apply a higher grade of strand, you can reach a higher extension. This is true. Whether you have a loss in ductility, whether you fail with a higher extension, today there are strand suppliers capable of reaching a very decent extension within the same limit of the extension we observe as a requirement for the 1860. But I don't know if I understand well your question is whether we have a more brittle material or not. Yes. It's not the case, but it's not either the same chemistry on this strand. There is a small jump between 1770 compared to 1860 to 2160. And there is a change in the chemistry of this material, permitting to have similar ductility compared to the 1860.
And this is approved by the international codes?
This strand is a new development.
No, is it
So whether the code is ready to absorb it, to accept it, not everywhere. Not everywhere. So today, the way to approve that use of strand is to make sure that a system exists which can accept it and still comply in terms of performance with the code. So this is what we have done. So we have taken that strand. We have modified the anchoring system to accept that strand. And then we have done testing and passed successfully the level of performance required as for a classical system. for stay cable. But if the next question is, can we optimize the structure by this use of strand? The response is technically, yes. Economically, not sure. I explain you why, because the cost per Newton of force is higher with that technology of strand. I told you it's a different compared to that technology of strand. So unless you have a clear technical reason that you need to go more compact, then it might not be optimum, this use of high-grade strand.
How much more expensive? Like 20%, 100%?
No, it's not this. It's not this. We're talking about a few percent. But this depends on the, if you analyze the global cost of the structure, and if you try to introduce into your cost all other parameters, if for the same quantity of strand you have higher force, you can reduce the number of strand, and maybe you save into labor costs, you save in many other places. But trying to save only on the pure kilogram of material is a waste of time. So this is a strand, we call it PTI strand, which is the strand as it is recommended or in the US, which has no zinc, and therefore has slightly better behavior sometimes, and slightly lower for other aspects. Talking about fretting, for example, is a bit less. Talking about ductility is a bit better due to the no zinc on the strand. VSL is making use for a specific concept, I will show later, strand without any sheathing and injection. And eventually, we're talking about epoxy-coated strand. VSL has reference experience with this type of strand, but VSL do not recommend the use of that strand.
And do you have epoxy-coated strands for states as well?
We have experience, but we will never recommend this technology of strand. Maybe we can discuss this. Why we do not recommend this?
Does it crack?
Why? Sorry?
It crack.
Yes,
Well, it's
correct.
It's getting
It
very
cracked,
famous
it-
on internal strands, but then
It
you
seems-
have a lot of wedge loss, etc. Right?
You have a huge setting of wedge, and you have a huge increase in relaxation. Today we are relying on this strand. Why? Because it has a very low relaxation. And now we introduce technology which is multiplying by more than 2 the relaxation. And on top of this, we have a test, and this strand has low redundancy, meaning that you do not lose one wire, you lose a complete section.
Yeah. It's a localized corrosion.
Exactly.
So you don't recommend just for the stay cables or for post-tension?
VSL position, I would say, is to do the best for the structure. And today we have not seen any advantage of using epoxy-coated strand in any application. Maybe we have overlooked something. Maybe we have missed a point somewhere. But for the moment, we do not see a technical interest in going with that strand for the moment. Talking about anchoring components or elements. So this is basically the standard state-of-the-art technology of anchoring a cable to a structure. 2 types of anchorage. One called the dead end, passive end, fixed end, depending on the vocabulary you want to use, and the other called stressing end or live end. Basically, you attach a cable with these 2 anchorage and you stress by the active one. You can stress by the passive one if you wish, but you cannot tune the force with the passive one. You tune the force by the active one. And where ESL has been developing lately is to introduce all these components you have here on the, I don't know if this works, you have here on the, yes, on this part here, we call it the transition zone of the anchorage. For the passive anchorage, they are integrated into the anchor head. The anchor head is a head, this piece of steel, where you have the wedge transferring the force of each strand to the anchor head. So we have all these parts here, which are, which are here in this transition zone, are introduced and concentrated inside this anchor block. This is kept for the active side for one reason, is because from this side you have to stress or tune the force of the cable. So there you don't know where stops the shading of the strand. and the sheeting of the strand has to stop inside the anchor block. So we have an extension which is required to make sure that we absorb this position of the sheeting stopping inside the anchor head, and to make sure the system remains tight during service and during installation. Do you have any question on this? So this anchoring system can be implemented into a structure, and there are a lot of different possibilities to do so. It can, at the bottom, for example, it can go inside a box girder, below a box girder, above the deck through a steel structure. It can be attached to a tower through steel structures, or through the tower, or inside the tower. Everything is modular, and there it's about design possibilities, how to connect it. And
Is there minimum space required for if it is inside the box girder for your jack?
here, for example,
Yeah, the first trick.
here or here, absolutely for the jack. Yes,
But like, is it VSL proprietary jack for the system?
correct.
So what is the minimum space?
So we can tell you it's 1 meter behind the head, for example. But then we can negotiate a bit on this one. For this one, we can work with much more smaller space on the passive side. On the active side, we can as well reduce the space. It's a detailing exercise. We just have to make sure we can do the operation which we are supposed to do, and from there we define what would be the minimum requirement space. It's a good question.
Are you using single strand jacks?
Absolutely, yes.
Sequences become really a headache, yes?
Not necessarily.
How many cables, strands you have got in one cable?
We go from 12 to, or 7 or 3 to 180 something 7. It's a repetitive exercise. It requires a bit of concentration.
And how long would it take to put the forces in one of those big number anchors?
Depending on the stay cable, because you have to thread the strand through, erect the strand, connect the strand, thread the strand.
No, just pulling it.
Just pulling it, it depends on the length.
Jacking.
Jacking it is, jacking itself on its own is 30 seconds.
30 seconds.
But then you have all the process behind. Threading the strand through.
No, I was just checking, because you said you have got 170 or 180 strands.
Yes,
So each strand 30 seconds.
yes.
Well, only for stressing.
Only for stressing.
Yeah, I know, that's where
The stressing comes at the end of the
I
installation.
know, but then that you have followed a sequence.
So you have to install the strand from top to bottom and stress it, and then move on to the next strand.
Making sure they are not entangled in between.
So here is an example of application of this type of technology of cable. And you can see cables ranging from, let's say, 50 meter to 400 meter long. So bear in mind, 400 meter long, to erect the strand is a bit of time as well. So when you have a 100 strand unit, 400 meter long, it takes a bit of time. We're talking about 2 days, 2 days and a half. It depends. But then coming back on this system and increasing the force again, then you just multiply the 30 seconds by the number of strand. And you ended up by having something like 15 minutes, 30 minutes, 1 hour, 2 hours.
Just out of question, you eventually have to give the bridge to somebody,
Yes.
and is it going to be a level submission or force submission? You're checking the forces that the bridge should be at a certain level, at a certain time, certain
Correct.
temperature.
This is, let's call it a discussion with the designer, what is relevant as parameter. What is very important is that a stay cable is like a structural element. As a designer, we cannot ask a stay cable to be at the same time at that force and that elongation, because they depend between each other based on how the structure behaves. Either you call for the force, you want that exact force, and then consequently you get this elongation as a consequence of how the structure has behaved.
No, I was
that
talking
force.
about the deck,
The deck, typically.
because the deck should be horizontal at a certain time.
Exactly, the deck should be at a given position. Let's call it the road design line. But then if you ask for a force to be there based on your model as a designer, and this force is such as after stressing the deck is a bit above or a bit below, it's not the consequence of the cable itself, it's the whole structure behaving. And what happens most of the time, especially in composite bridge, is that the stiffness of the deck
can I just say something here?
Yes, please.
Because most of the people here are building designers.
Okay.
And they say, this is up to the contractor to do it. They don't know the bridge designers go through that to come up with all the balancing force, go through the sequences. That's what I want you to say, because most of the people here are building designers. How many bridge designers here? Yeah, so you understand that part, yes?
Thank you. Thank you very much. No, it's true. A deck is a very flexible structure, and the geometry is given a lot by the stay cable themselves, but the support force you have. And tuning the deck geometry goes through tuning the cable lengths. And of course, it's more convenient to call for the force from the designer, give me the force, but then you lose on the geometry. So better to go for geometry, and then let's check the forces within tolerance and within where we want to be. It's a better way of proceeding. Yeah, correct. We are okay on that part of it. So I just make a. This is a development that VSL has started like 15 years ago or 20 years ago. We call it the dehumidified system. We depart completely from the requirement we have today, or the recommendation, which calls for having strand with wax injection, sheeting, a lot of petrol-based material inside. And we replace this passive corrosion protection into an active corrosion protection. How it works is the stay cable system, or the steel main tensile element, including the anchor head, they are in a fully tight encapsulation, and the air inside this encapsulation is dehumidified. The water is removed from that air. This technology is today well spread into protecting corrosion, the deck structure, for example, or box girders in steel. And it works extremely efficiently for cables. Today we have a catenary cable of suspended bridge making use of this similar type of technology for corrosion protection. And VSL has piloted this solution, and today we will try this solution, quite disruptive, which is far away from recommendation, into a project in Hong Kong. Why Hong Kong is because it's very humid and hot, so very aggressive for corrosion, and therefore we have the best field situation for testing the technology. The advantage of this technology is because we have removed all this material, we can make the stay cable much more compact, and we can combine this together with an existing dehumidification plant working for the deck, for example, as a box girder.
So is it a continuous process, dehumidification, or it's like done at some intervals periodically?
If you see that graphic here, this is basically the corrosion rates according to humidity. And what you find out is with a relative humidity of 60% and below, you have almost no corrosion. It picks up quickly, very fast afterwards, but below 60%, no corrosion happens. And all dehumidification plants, usually they work at 40%. So the idea basically is to have a closed loop of dehumidification. This is a principle applied to this Hong Kong project, for example. So you have you keep retreating this air, and your machine is just here to gather for leakage. So as soon as you have leakage, you have to refeed with dry air, so you dry only the piece of air you add on top in this circuit. And you come at the end of the day, if your system is perfectly tight, the machine works for the first 2 weeks and then finished. If your system has leakage, you keep a little bit. But we are very far, far away from, in terms of consumption, electrical consumption, we are far away from the manufacturing process of the strand itself with the sheeting and the wax and so on. So there you have a global optimization, especially in terms of energy. And today it's quite fashionable to talk about energy saving. So if we move on other technology of stay cable, clevises, I think there is a project in Dubai making use of this type of solution. where VSL has been developing is to have a Clevis stay cable system which has similar type of performance as a heavy-duty stay cable system, not to reduce the capability of the system by having a Clevis. So the testing regime of this solution is similar to the other one, which is FIB and FIB30. So there we have, again, a passive end, the active end, and the force is tuned by threading on this rod into this socket by use of a jacking system. The system is for heavy-duty application. We're talking about a small number of strands, so let's say light stay cable, but in terms of fatigue loading, the objective is to reach the same capacity of the conventional system with this classical 2 million cycle test, 20 megapascals reservation, and so on, and dynamic deviation of the cable. Coming with stressing equipment and, of course, application, mostly on arches. This is where we have most reference for this type of technology, or roof cable, for example. The important is since we are using exactly the same technology of termination with wedge and 7-wire strand sheeted, you can make multiple of it. You can apply, for example, a Clevis together with an anchor head. You can interchange components. It's modular. You can, for example, if I come back here, attach on top a Clevis, and at the bottom having a stressing head like this. Roof application. Now we talk about saddle. Saddle system has been an extremely successful development of VSL. Saddle is the original